Today we are going to use another method to solve quadratics. So far we've used three methods. We have actually four methods. We have graphed quadratics, and when we graph quadratics we see where the solutions come from. They are the x-intercepts, and that's what we're looking for here. That's why it says x equals in this case. We've also used factoring to solve. We've used square roots and completing the square. So we saw that factoring was the fastest method. However, not all quadratics can be factored. And here, when we use completing the square, we ended up with some problems that were difficult to deal with, especially when there was a number, a coefficient out in front of the x squared term. So now we're going to use this thing called the quadratic formula. And it's derived from completing the square, which we'll take a look at later. But for right now, this is what it is. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. If you can memorize that, you can solve any quadratic. And that's what's neat about this method, is you can use it for any quadratic and get the answer. Just like completing the square, however, it's a little bit faster. So when we go ahead and look at this one we could go ahead and factor a whole lot faster than I could using this formula. But if we didn't know how to factor it, this would be a formula to use. So a is the number out in front of the x squared term. B is the number out in front of x. And c is the constant. So again, it always goes in that quadratic equation that I gave you, ax squared plus bx plus c. So the important thing to remember is that you have to have it set equal to 0. And that's what we have on these problems, except for this last one here, or the third problem. So let's take a look at substituting the numbers in. It goes x equals, and then we take the opposite of b. So negative 4 plus or minus the square root, and then it's b squared. So 4 squared minus 4ac. So 4 is one of the only numbers that always is in the problem, that and 2. So 4ac, so 4 times a, which is 1, c, which is negative 21. And then this is all over 2a, 2 times 1. So we do some work there. We have a negative 4 plus or minus the square root, and then we take this 4 and square it, we get 16. And then we have two negatives here, negative 4 and negative 21. And so that's why it's going to end up being a positive sign here. And so when we multiply those two numbers, we end up with 84. And so from this point, this is all over 2. And so we do some more work there. We have negative 4 plus or minus the square root, and then we can add these numbers together. And that gives us 100 all over 2. So now we're ready to solve a little further. We can take the square root of 100, and that is 10. So now we have negative 4 plus or minus 10 over 2, and then we can set up our two problems. So we've got negative 4 plus 10 over 2, and we have negative 4 minus 10 over 2. So we do some work there. This makes a 6 halves, which makes 3. And over here we have negative 14 halves, which ends up being negative 7. And so those are our two x-intercepts, two roots, two solutions is another way to state that. So this next one we have a different a value. A is 3, b is 2, and c is negative 1. So we can use those because it's set equal to 0. So we go ahead and substitute into our quadratic formula. Remember, it goes the opposite of b plus or minus the square root of b squared. So 2 squared minus 4 times a, which is 3, times c, which is negative 1. This is all over 2 times by 3, 2a. And so we do some work there. We've got now x equals the opposite of b, so negative 2 plus or minus the square root. And then we have 4, and then negative times a negative makes a positive, so plus 12, and this is all over 6. So now we have x equals, and then we go ahead and do this work. We have negative 2 plus or minus the square root of 16, all over 6. And so when we go ahead and take that square root, we're left just with 4, so negative 2 plus or minus, and then the square root of 16 we said was 4, all over 6. And so we do some more work there. And we set up our two problems. X equals negative 2 plus 4 over 6. And then you see how we have that minus sign. We have another one. We also have negative 2 minus 4 over 6. So when we go ahead and do some more work there, we have x equals 2 6, which reduces down to 1/3. Over on this other side, we have negative 6 6, which reduces down to -1. So those are our two x-intercepts. So this formula takes definitely a little bit longer. These two problems, we could have factored the problems and came up with the answers a little bit quicker. However, this method always works, so you can always fall back on it if you could not factor. Well, this next one we have to do some extra work here first. We have to subtract the 72. You always need to set it equal to 0 first. So now we have x squared minus 6x minus 72 all equals 0. So from this point, I'll go ahead and use that quadratic formula, substituting these numbers in. The opposite of -6 is +6, plus or minus the square root of 6 squared, so 36 that'll become, minus 4 times a, which is 1, times c, which is -72. This is all over 2 times 1, 2a. So we go ahead and do some more work there. We've got 6 plus or minus the square root. This makes 36, and it becomes another plus sign here because of the negative and the negative. Always watch for that. Odd number of negatives, it'll be minus, but an even number, it'll be a positive. So doing that work, we get 288. And this is all over 2. And so we do some more work there. 6 plus or minus the square root. Adding these two numbers together, looks like we get 14, and that makes 11 plus 1 makes 12. And then 2 and 1 make 3. 324 all over 2. Well, when we take the square root of 324, it is a perfect square. It does make 18. And this is all over 2. So we do some more work there. Remember, we got our two problems to set up. 6 plus 18 over 2. And we also have the 6 minus 18 all over 2. So we go ahead and work this part. 6 plus 18 makes 24. Over 2, which makes 12. On the other side, we have a -12 over 2, which gives me -6. So our two x-intercepts. Well, the next one here, we've got a 6 is our a term. We've got 1 is the b term, and c is -1. So we just substitute those numbers into our axis of symmetry formula. -1 plus or minus, I'm sorry, not axis of symmetry in this case, the quadratic formula. -1 plus or minus the square root of 1 squared minus 4 times 6 times -1. This is all over 2 times 6. So we do some more work here. We have a -1 plus or minus the square root, and then here we have 1, and then this is a times sign here, so it's negative times a negative, so another plus sign, plus 24, all over 12. So now it's a -1 plus or minus the square root of 25 over 12, which we can take the square root of. So the square root of that 25 is 5, so now we've got -1 plus or minus 5 all over 12. So we can set up our problem, -1 plus 5 over 12, and we have a -1 minus 5 all over 12. So this first one makes 4/12, which becomes 1/3. And the next one is -6/12, which we can rewrite as -1/2. So those are our x-intercepts. Well, those are some of the problems that you'll see on tonight's homework. Good luck.